pressure, not see those
From
doing what we want, especially as John's comparing with that as well. From a layman side,
yeah. Wow. Good evening, ladies and gentlemen, and welcome back to Heavy Repping. My name is John Davidson, and I'm here once again in our super best fancy science test location in the southwest of England. So for this week's episode, we're making a return to the science. But it's not just any old episode of the science. This week, I actually had an opportunity to go to a factory and see injection moulding happening in person, which was incredibly cool, and I'm going to share all of that process with you. So a big thanks to both Paul at Switchpick and Ewan at Avalon Plastics in Glastonbury for giving me the opportunity to do that. Before we get started though, this week's shout out goes to Sun, because now injection moulding is an incredibly important process that you'll see everywhere in life, from things like this light that I use, to garden chairs, to buckets, to routers for your internet, and, for our purposes today, for plectrums. All of your stuff that's made from Delrin, nylon, acetal, all that sort of stuff, that's all made using injection moulding. I had the opportunity to go to Avalon Plastics and film a number of parts of the process. Now, of course, because of the nature of intellectual property and so on, I couldn't film everything, but I've been allowed to show you very key parts of the process, which will give you a healthy overview as to how this whole thing works. So, without further ado, let's go. The process begins with plastic pellets being taken from huge bags and fed through vacuum tubes to the factory floor. Some materials need to be dried before being fed into the machine, like glass-filled nylon, in which case they pass through drying hoppers before they make their way out to the machines. The pellets are then fed from the hoppers into large chambers, which are inhabited by reverse feed Archimedean screws, and those screws feed the pellets along a path into a heated chamber, which brings them up to way past 100 degrees and into a liquid state. Using very high pressure indeed, that screw then forces that liquid through a tiny hole into a mould, referred to in this instance as a tool. The pressures here can be anything up to 200 bar, which is roughly the equivalent of about 2900 psi, in order to push this molten plastic through this tiny aperture. The molten plastic then comes through the centre of the tool and forms the sprue. Now, because you guys are incredibly lucky and I'm on the front lines of the Plectroverse, this came from the factory tour. This is a discarded sprue, and that came out of the tool. This bit here is referred to as the sprue, and these little sections here are the runners. The runners go down to two different ends. This bit here is known as a gate, this flat bit, and that is what you will have your pick coming off if you see anything from Dunlop, like Dunlop nylons. You've got that little rough ridge bit at the top. That's because this is the bit they get broken off when they come out of the tool. And this bit here is called a drip. Now, the drip is slightly different in the sense that it's a little more expensive to tool up, but basically what that does is when you break that part off, say we got one of these, if you break the part off of that, this doesn't leave a tang on the top of the part, and that is mostly for customer facing parts. It's stuff you're going to see all the time, so it looks a little bit neater. For this, it kind of doesn't really matter if you can see it or not. Now, one of the things that's really important about these is the fact that these are completely unique to whatever tool it is that is being used. So the ones for the picks don't look anything like this. This is for something. These go back into the machine in a process I'll talk about in a minute. For a company like Switchpick, who are making very small things, the tool that they have crafted is this steel block with interchangeable plates. Now, the reason for that is that down the line, if they want to change, say, the thickness of the pick while keeping the design the same, they can remove that plate and put another plate in without having to retool the entire block. Companies that are making larger things, like say chair backs or something like that, like those bendy chair backs that you get, they will have a much larger steel block, and the whole thing's just cut into that. That goes into the machine, the screw feeds the material through into that block, the plastic then goes through like this, feeds out into the mould in question, that gets cooled, the block comes apart and the part falls down, that's then fed off a conveyor belt to the outside world. Now the machines in question, apart from being way bigger than I thought they would be, also have the propensity to run for anything up to and including 24 hours straight, where they're producing hundreds and hundreds and hundreds of pieces. Now this means that you have very high consistency in parts. There's actually very little waste. I'm going to come on to that in a minute. And it means that you don't actually have to have that many people to run the machine, which is why it's so cost effective to do it. Once you have built the tool, once you've crafted it, that can then be used to generate hundreds of thousands of the same thing over and over and over again, which is very common in the industry. The consistency thing, especially when we're talking about picks, is really important, because if you go from one shop to another, or say you're somewhere else in the world, if you're from the UK and you're gigging in France, or you're gigging in Japan, or you're gigging anywhere, you can go into a shop, and if you're buying stuff off the counter from one of these, it means that you can take out a nylon pick and it will be exactly the same as a nylon pick you'd buy in the UK. There's an incredible consistency between parts because they're all being cut using exactly the same process from the same machine, and that is incredibly important. Now I want to talk about recycling, because that's a really big thing, not just in this day and age, but in general. Avalon Plastics, for example, does about 40 tonnes a month in recycling. So these bits, once they come out of the machine, your part gets pulled off, this will then go back in, get remelted down, and it will come back in pellet form to be used for something else. Now, the only thing with that, as you've probably worked out, is that once a material has been through the process, it's been heated up to the point of being liquid, then cooled down again and solidified into something. Once that has been through that process, it does lose a little bit of its quality. However, you don't always need to have some rock hard part for everything, and also not everything is going to be seen by the public. A lot of little plastic bits that go on circuit boards or go inside amps or get used for knobs or anything like that, little tiny things, anything that's going to get hidden from the public eye but is still an important part, can be made out of that material. So at the moment, Avalon Plastics does about 500 tonnes a year of recycled material alone, which is quite a lot. It's also worth noting that, as you can see up here, these little black pellets are made from landfill. There's now an initiative in place whereby anything and everything that can be made back into a component part, literally anything, will get taken from a landfill, crushed and melted down. They are then repurposed for making other things. So it means that although there's a lot of waste material, and we do produce a lot of waste material as a species, a much higher amount of that now gets repurposed into making things, and the cycle begins again. So although injection molding from the outside, if you're talking about hundreds of thousands of units made of hardened plastic, seems a bit on the wasteful side, the industry itself is doing an enormous amount to try and reduce the amount of waste by repurposing as much of this and as much of the landfill as possible. So I hope this has been of use to you. I'll be back next week with more information from the Plectroverse. I would like to say another big thank you to both Paul from Switch Picks and Ewan from Avalon Plastics for giving me the opportunity to go and see this science in action. Just remember, my name is John Tron Davidson. This is heavy repping, and I will see you soon. So, whatever's going on in your life, remember, rep hard, rep heavy.